Here's Unit 7, Day 3. We're going to be simplifying radicals and rational exponents. Our objective is still that we're going to know how to use exponent rules are used to simplify expressions. We're going to understand that rules only affect the same base or like bases, and we're going to be able to simplify expressions using exponent rules. Okay, so this is a warm-up. You get to choose from the numbers 1 through 9 to make the expression true. Okay, doesn't matter what numbers you choose. I'm going to pause right here. I hope that you pause on your end and then just try to figure it out. What numbers can you use, okay, to make this into a 10, to make those numbers actually come out. Okay, so I guess I should have said that you could use negatives because that's the only way that I was able to get some of these numbers to come out. If you were able to get it with positive numbers, great, but I think you were going to be able to have to use, I'm going to have to put that in. You may use negative numbers. There we go. All right, and so here's an example. It's not going to be the exact same one as you do. All right, so now we're going to go to the next slide. Okay, so here's the parts of a radical. You have the radical symbol, which you call square root when there isn't an index. An index tells you how many times do you want to see that number repeated inside so that it can come outside of the square root. The radicand is what is inside the square root or the radical symbol. I'm going to say radical because I need to use the correct terminology. The radical is the whole entire thing. Index is, if it's not shown there, then it's automatically going to be a 2. So I'm going to be simplifying square roots to begin with. You have b to the n is equal to a. So then it's doing the opposite operation. You're squaring something or you're raising something to a power, then you're going to take the nth root of that to get the original base back. The n represents how many times the number must be inside the radical before it can be outside the radical. Some numbers will have to stay inside if it's left over. Here's example 1. So we got 27. The index is not there, so it's 2. All right, 9 times 3 gives me 27. Well, I need to factor this out all the way into its prime numbers. I still put a 2 there. Okay. The index is 2, so it tells me that I need to circle 2 3s. So I move my circle, and it's a little bit big, so I'm going to have to move it over. The number of circles that I have tells me how many times I'm going to take that number out. I only have one circle. That means the 3 can only show up one time outside this radical. I don't have to write the index of 2. That was just helping me to figure out how many I needed to circle. And there's only one 3 left. So the answer is 3 square root of 3. Okay, let's go to the next. Here's example 2. There's still a 2 here. I'm going to go ahead and do that one. Remember, just a double click so you can type in 12 times 2, 4 times 3 times 2, and then 2 times 2 times 3 times 2. Remember, I'm only going to circle the one that shows up twice because this says a 2, so I have to have 2 of the same number. I'm going to shrink this down. I only have one circle, so that means the 2 is only going to come out once, and I have 2 numbers left over. So anytime I have more than one number on the outside or more than one number left on the inside, I have to multiply them. So this is my answer. Okay, let's go on to the next one. Here's example 3. So there's a third root of 1,000. So we put the 3 here. We know that 10 times 10 times 10. Hey, I got all that. Oh no, it was 10 times 100, right? All right, and then 10 times 10 times 10. We have a 3. And then we can break this up. Anytime a number ends in 0, you might likely be able to divide it by 10 or by 5. There's a lot of division rules that you want to take into account when you're doing simplifying the radical. But what you really want to try to do is just, if it's even, divided by 2 or 4, try to get it divided by bigger numbers so you have less work to do. odd numbers are always going to be able to be divisible by 3, 5, or 7. So take that kind of account, okay? And you got only one circle and there's nothing left over, so the answer is 10. There we go. All right, so let's go ahead and try this. I know it's an even number, so let me try divide it by 2. So I'm going to get a calculator. 126 divided by 2, that's 63. So 2 times 63. I know that 63 is 7 times 9. And then I know that 7 is 3 times 3. All right. I don't have 3 of the same number. I don't see the number 3, one number 3 times, so I don't have anything to circle. So sometimes when I don't have that, you just can't be simplified. You leave it as this right here. That would be your answer. Okay, we're going to go on to the next slide. Okay, well, now we're going to be talking about rational exponents. What a rational exponent does is that it's a fraction. So you're expressing the radical as a fraction. The index will be the number that's outside the radical, and the e stands for the exponent. So the e is the numerator, the exponent, and the I, the index, is the denominator. Okay, so let's try this one right here. You have 1 over 4, so the index is the denominator, that's 4. 1 is the exponent in the numerator, and then we go x. Here, the denominator is 5, the variable is y, and the exponent is 1. Let's try to make this a little bit bigger because it's really small compared to the exponent, right? It's just so small. It doesn't even look like an exponent. All right, 78. So let's just do this one, type this one, 78, and we gotta mess with that so much. There we go. All right, so we're gonna practice writing those from the rational exponent to the radical form. Okay, I want you to do this one on your own, and I'm going to pause, and I want you to pause the video and then do this and then come back and see if you got the right answer. Okay, hopefully you got the same thing I got. All right, let's go on to the next one, and let's talk about how we can simplify the radical when it has variables. Okay. Oh, I'm not sure. I guess I jumped the gun, like they say. I don't know why that came. We're going to practice more of this first. Sorry. Let's talk about this one. All right. It says in order to translate more, you're going to have to look for a common denominator. Okay. Well, common denominator is that you look to figure out what, I don't know if you remember this from, I guess it was junior high, or I'm not sure. Okay. So you take the 3 and you figure out, all right, I know it's 3, 6, 9, 12, 15, so on. And then I know 4 is 4, 8, 12, 20, 24. I know that 2 is 2, 4, 6, 8, 10, 12. I look for the number they have in common, the smallest number they have in common. All 3 of them have to have this in common. So right here, it's 12 is the one they have in common, because 6 and 6 is the smallest, but only number 3 and 2 have that in common. It has to be all 3 of them. And then 8, only the number 4 and the number 2 have that in common. You have to have a common denominator. All 3 numbers have to have that. Okay? All right, so that means we're going to have the number 12 out here. Now, if you remember, you figure out what number do you need to multiply 3 by to get 12, and you have to multiply that number to the numerator. So 3 times 4 is 12, 2 times 4 is 8, so 8 goes here. 4 times 3 is 12, so 1 times 3 is 3. 2 times 6 is 12, so 1 times 6 is 6. Right. We're going to do the same thing over here. We're going to find the least common multiple. And I'm going to leave this box here for y'all, but I'm going to delete the Y'all know that y'all have to write in there yourselves. All right, so we're only doing 3 and 7. 7, 14, 21, 28, 35. All right, they don't have anything here, so we got to keep going. 18, 21. Ah, there it goes. 21 is the one that they have in common. I need to undo that one. 21, 21. So that means the index is going to be the common denominator, which is 21. I got to get this one to be bigger. Okay. And then we figure out 7 times 3 is 21. So 3 times 3 is 9. 3 times 7 is 21. So 5 times 7 is 35. All right, so now we're going to do simplifying radicals with more variables. All right, here we go. So we're going to simplify with the radicals. So we're still going to do the same steps about getting the 128 reduced down. Okay, and if you notice I did that, I got circled 4 2s and I got 3 left over. So when I multiply those, I get 8. Now to do the variable, we have to divide the exponent with the index, and the whole number comes out of the radical, the remainder stays inside. So 4 goes into 8 2 times. That means I have 0 remainder. Okay? That means that there is no variable inside. Okay? There is no variable inside of the radical. It's only the 8. Okay, let's practice some more. So I went ahead and reduced it 4 times 4 times 4 times 7. And then I converted all those 4s into 2 times 2. The index is 6. So I need 6 of the same. 1, 2, 3, 4, 5, 6. Okay. Send back. Y'all can see this. There it goes. Like that. Send forward. Bring front. There you go. There it goes. All right, now we need to cover the 2s. All right. The 7's going to stay inside because it's the only 7. I know I'm going to have a number 2. All right, so I do the first letter x. I do 7 because that's the exponent inside, and then 6. Notice I'm doing every variable by itself. I'm going to get 1 with the remainder of 1. Okay, because 6 goes into 7 one time with the remainder of 1 left over. I do 7, 6, and then it's 1. 6 goes into 7 one time with the remainder of 1. That remainder is the one that's staying inside. So that means we're going to put x and y in here. Do the 6 in here, and then there's only one x and one y that came out. All right, let's go practice another one. Okay, so we'll do 16, 8 times 2 times x times y, and then 4 times 2, 8 times 2, 3 times x times y. The exponent is 3. I need to do 3 2s. Order, send back. Get this and send forward. There we go. All right, and then we have the index is 3, but the exponent is 1. So there's 0. You can't divide it, so that means that no x's come outside. We have the same thing with the y, so no y's come out. Okay. That means we have 1, 2 that's going to come out, and we have what is it, 2xy left inside, and the exponent is 3 up here. Okay, we got one more, and then it's going to be you guys. Oh, no, we have 2 more slides, and then it's going to be you guys doing independent practice. Okay, here we go to this one. So I kind of gave you an idea of what you needed to do. I'm like, all right, we're going to have to work with fractions. Everybody's always having such a hard time. So this is what we're going to do. Use the roles of exponents to simplify the following expressions. I did the Desmos practice right there. We're going to click on it. Remember to choose Texas in here, calculator, and then what we're going to do, there. We're going to try to add the fractions because we know we're supposed to add them. Sorry, I got an email from a teacher. Let me pause this real quick. Sorry, guys. It was from a teacher from my daughter. All right, we're going to add the fractions. So let's go to here. You do 1 over 3 plus 1 over 4. Now, you see this little circle with the fractions? That's going to convert whatever the answer was to a fraction. So we got 7 over 12, which means we can come back, do 7 divided by 12 there, and know that my index is the denominator, and my exponent is in the inside. Here it goes, and then this would be 7. I feel like I have to make this one smaller so that it will fit in. Let's see if we can get that to fit a little bit better. There it goes. All right, so we do this one. We're going to do the division, so it's going to help us out. 2 divided by the fraction, which is 1/4. And we get 8. All right, so it's just 8. Oh, no, Miss Jimenez. Ooh, Miss Jimenez did it wrong, right? We said subtract. Oh, look at that. Subtract 1/4. We get a decimal, we do the fraction, and we get 7 over 4. So 7 divided by 4. That means the index is 4, because that's the denominator, and the inside is a 7. All right, we do this one. We're just multiplying fractions. 2 over 5 times fraction is 3 over 4. So we do the fraction part. We get 3/10. 3/10, which means the index is 10. All right, and then we get 3 in the inside. All right, now we do this one. We're writing it as a radical. 3. Why are we rewriting it as a radical and not having to do any multiplication? Well, because the top numerator is a 1, so that means nothing is happening to the exponents inside. So 3x, the 2 is staying the same. We space so that we can get the y right there. All right, so we're going to practice on the next one as well. Okay, here's the last example, and then we're going to have to do your independent practice. Okay, so we multiply the 2 numbers and we get 12. And then we're going to multiply, we're not going to multiply, we're going to add the fractions. So 2 over 5 plus, remember to get the right arrow out, plus 3 over 4. Do the fraction right here, and we get 23 over 20. Means this is going to be 20. No, what do we have to do? Divide. 20 goes into, well, 20 has to go out here, because that's the thing. But 20 goes into 23 one time, so that's why we got an x left, and then we got 3 left over here. So that one was okay. All right, this one we're going to subtract, so it's going to be 1/3 minus a negative 1/2. We do this, and we get 5 over 6. 6 in here, 5 in here. Remember, the index is the denominator, the exponent's on the top. All right, now we do this. Means 16 is also going to be raised to 2 over 5. Not showing. And then this is going to multiply. So 230. So let's figure out what this is going to be. We have 2 over 5th right here, so we have to get a common denominator. The common denominator would be 30, but that means I have to multiply this by 6 and multiply the bottom by 6 to get the common denominator. All right, so then it would be 30, and then 16 is in here. All right, so let's go ahead and simplify the 16. We got to figure out what's that going to match. So 16 to the 12th power. That's going to be 4 times 4. That's 2 16ths, 3 16ths. All right, let's see if we can use a calculator. It'll be a little bit better to figure out what this is going to be. So 16 raised to 12 over 30. Okay, so that means it is going to come out somehow. Okay, 16 to the 12th power. Let's see how well we can do this one. Oh, that's a big number. All right, so we know 16 is 4 times 4. And that's another one. And I need 12. Okay, out of those 4, that'd be 2 times 2 times 2, 2. Okay. 4 times 4 is 16, and that's 16. That gives me 2 16s. And then out of those 2 16s, I get, that's 6, that's 4, and then another 2. Okay, out of those, I get 1, 2, 3, 4, 5, 6, 7, 8. I need 12 2s. 4, 8. So that's okay. So that's how many 16s? 1 16, 2 16s, 3 16s. Okay, that's 3 16s. You know what? Maybe we should have just done 16. It says 5 over 6. Let me get this. Okay. 16, and it was 5 over 6. So let's go back over here. It's 5 over 6. I'm sorry, not 5 over 6. It's 2 over 5. All right, so let's do that one because that's a little bit easier to handle. All right, so that means you have 5 on the outside. And let me copy this so we can use it. Here. We're going to put 16 in there. And that's 16 times 16, which would then come out to be 4 times 4 times 4 times 4, which then would be 2 times 2 times 2 times 2 times 2. One, 4, 2, 4, 3, 4. 1, 2, 3. Times. Do I have any 5s? 1, 2, 3, 4, 5. I have 5 with a remainder of, let me pause it, sorry. Okay, so we got 16, 16, we dropped it down to 2 4s, 2 4s for each. We dropped out the 4 and gave it 2 each. We need 5 so they can come out, so that's 3, 5. I'm gonna highlight that. So the 2 is gonna be able to come out, okay? But we have 3 left inside. So it's an 8. But it has an exponent of 5. Oh man, this one's tough. Alright. Let me work it out first and then I'll come out. I can't believe I did this one with the 16 in there. Whew, I should have done a smaller number. Alright. Give me some time. I'm not gonna make y'all do this one. Okay, I'm gonna pause pause it right now. I'm going to come back into the answer. I'm not going to make you do this one on your own. Not at all. So, sorry. Okay, so I did it by hand. This is what you would get with the fraction, but I wanted to go ahead and simplify this. I don't know if it's just the math teacher in me that wouldn't let me leave that alone. This is what you would have gotten because you got 2 over 5, and then you made sure that they had the same denominator, which was 30. So we got 12 inside, 30 on the outside. But I didn't want to leave this alone. I wanted to go ahead and make sure that we knew how to simplify it. So it takes a longer time to do because you would have to convert all the 16s into 4s and then all the 4s into 2 to get the actual factored form of 16. All right. What I noticed was that I converted 8 16s into 2s, 2 by 2s, and I got 32s. And then that 2 would come outside, but it would still leave me with 4, 8, 12, 16, 18 twos. Okay. So if we use the calculator, 2 to the 18 is that big number. But I'm going to do this. I'm going to get this box right here. Over here. We're going to put a 2 right there. Because there's going to be a 2 that's going to go there. Order. Send to the back. We're going to make sure to increase this so it could be a bigger number. Even bigger. Okay. And then we would change this to a 2. And then change this to an 18 because that's going to be 18 twos inside, and then you got your x, and that's a more truer form. It took me a lot longer to do that, but it's just, I guess my heart wouldn't let me leave it as a 16 over 12. Okay, but you don't have to do that. I just wanted y'all to get the same denominator. Okay. All right, so that one was a pretty tough one, but your independent practice is easier. Okay, just make sure you get that done. Make sure you practice a little bit before you actually take the checkpoint. All right. Okay, there was no major grade this week. It was just nothing but daily grades.